So once again, we apologies for that technical issue. So we are taking on the topic, taking benefit of machine learning modeling, irrespective of your background, and making sure you are doing it right. Under our important clarification series with the team, always let the data speak. So AI, as we know, is taking the world like a storm, especially the subfield of machine learning, which is also just a topic or a subfield under AI. However, it has distinguished itself as by far one of the most, if not the most important aspect of AI, because even other fields of AI, now they need machine learning to make them excel drastically. For example, it was when machine learning was brought into natural language processing. Natural language processing has been long, it's been here with us for a long time. However, with the incorporation of machine learning into language model, then we start hearing of the LLM, the large language model. Robotics has been here for long. However, with the integration of machine learning, it's taking robotics to another level. So that is the concept we're looking at. So irrespective of your field, you are highly welcome to learn and see how you can implement this interesting concept in your own area of endeavor. We've had in the past series of our videos, which says like why you can no longer ignore AI and machine learning. So it's become very clear to discerning mind that yes, this is where the world is going. So this is one of these why we set up this kind of platform to give opportunity for everybody to be able to learn in an easier way. So devoid of the coding struggle at the beginning. So once you understand what you are really learning, what is AI machine learning, then interested in coding, then you can push it up to another level of coding. However, bearing in mind the fact that coding is totally different from AI. So why should we discourage people from learning it? Because of the difficulty they do encounter with coding. So we came up with this no coding idea that you can still learn and use AI and machine learning without even writing a single code. So this is why we usually practice some of this, what we learn here in the weaker environment, which is very easy to use. GUI, graphical user interface based machine learning platform that we've been using. So as stated, irrespective of our background, let us know that these are the basic building block of machine learning. See, we call it the iterative machine learning model building framework. It is iterative. That gives you a kind of leverage. You don't have to get it right at once. Start with your data, move to the algorithm. There are some pre-processing preparation you have to take. Do the minimal possible preparation and move on. You can always come back to do more if there's need for it. This is in line with what we call let the data speak. If you do excessive preparation, pre-processing, you may indirectly lead yourself to the problem we call mutilation, data mutilation. That is, you've destroyed the inherent characteristics of the data set. So we try to use the data as close as possible to the original data gotten from the source. Because the real life application you want to deploy is going to be using real life data. So that is why it's always good select your data, test it as close as possible to the original one. So no excessive preprocessing. Do the minimum, because there are some preprocessing that your algorithm may not work with. For example, if you have missing value, support vector machine and some host of algorithm may not work. But decision tree will still work even when you have missing value. It will work because it has inbuilt capacity to deal with missing value. So you do what is most important, that without it, there may be error for you, and you move into the modeling stage. Here you select a particular algorithm, maybe k-nearest neighbor, use it to run your data. You check the performance, then you go back to do the hyperparameter optimization. Do what we call the hyperparameter optimization. See? And then check the result again. You keep going back doing the hyperparameter optimization until you get what you desire. Sometimes you may not be able to get it with the algorithm you selected. Maybe you need to try another algorithm. You are still moving back here. Try decision tree, try support vector machine. But the principle is start from simple to the complex. Start from simple algorithm. Logistic regression, k-nearest neighbor, decision tree. Then gradually you start moving towards complex algorithm, support vector machine. Sometimes you might have to come up with ensemble. That is what we call mashakel in Arabic. Cocktail, we call it cocktail. When you have cocktail, mixing algorithm together to be able to get what data is saying, because every data comes up with something, with a whisper. Data is whispering something, but we cannot hear it as human beings. So machine learning is trying to help us understand what data is trying to say. So we have to do in the right way that we don't miss the whispering that is coming from our data set. Okay? And that is why we have to be careful that we don't destroy the data set. It came with something. Try to look for the appropriate model that will be able to understand what the data is saying. And the spectacular thing is there is no algorithm that works in all situations. This is what we call the no free lunch theorem. No free lunch theorem. See, that is, I used algorithm A on my problem last week. It worked excellently well. It doesn't mean when you have a new problem to solve, it's going to work. No, you'll be surprised. It may perform so poorly because it's not able to understand what that data is carrying along. The whispering of that data is not clear to your algorithm. You have to try other algorithm. And that's why you have to have very open mind when you implement AI, especially machine learning. So bearing in mind that there is no free lunch anywhere. And machine learning, like I have to say, it's a tool, it's not a dogma. It doesn't solve all problems. You have to look at the specific problem. This is what you need. You really need machine learning for it. So once you do your hyperparameter optimization, you can change the algorithm. Sometimes all these algorithms may not work for you. Changing them may not help you to get what you need. You may have to go back to feature engineering, prepare the data more, do more pre-processing. Maybe I need to normalize my data. Normalize my data. See, do I normalize my data set? Some people, once they get the data set, they normalize it. This is wrong. Totally wrong. It doesn't follow the principle of let the data speak. We have seen data set that's not normalized, performing better than the one normalized. Because this data set they used to come with their own unique nature. We have to play along with it. Let the data itself decide which part of his body, which part of his variant is more useful to you. Is it the normalized data work for you, or is it the one that is not normalized? So you run the experiment using the original data, keep the result, then run it using the normalized data, keep the result. Do feature selection, keep the result. You remove the noise, keep the result. Keep trying multiple pre-processing on the data set and keep experimenting with them. and then put it on the table and then have a decision which one is getting me better result. This is why this iterative framework is very, very interesting. And we already made it even more clearer in the modified iterative machine learning modeling framework to support let the data speak. You can see as you are moving back here, you have some of this you can do. You can do hyperparameter optimization. You can change the algorithm. You may make ensembles. You may make hybrid, etc. There are so many other things you can try while going back to just the previous step. However, we told us once you do hyperparameter optimization, you change the algorithm, you can hold on for now. If here you are not getting good result, maybe you may go back and try to do normalization before you come build ensemble, because ensemble is going to take you a lot of time. Normalization is very easy. So once you have changed, you have done the hyperparameter optimization, you have checked you change the algorithm, try couple from simple to the complex. You may stop at that for now, because to build ensemble takes time, take a lot of resources. It's time for you to go back. Go back totally. Maybe you need to handle the missing value properly, outlier treatment, try to reduce the noise, you see? Or you may have to normalize the data. You may have to carry out log transformation to reduce skewness in the data. Sometimes when you carry out log transformation, it may make your data to be able to speak well. The algorithm may be able to manage and get the insight in your data. See? Sometimes you may have to construct new attributes. This is what we call feature engineering. Okay, this attribute seems not to be having good information for me. We are not getting good result. Okay, create a new attribute from available attributes. However, never use the output to create attributes. We've seen this in practice. People try to create a new attribute. Now they are using the target variable as one of the variables to generate the new output. That is wrong. We call that data leakage. Data leakage. See, once your model has access to your output, you are creating a feature to be used in building the model using target value as one of the parameters for the new feature. No, you don't do that. See? And even when you do the hyperparameter optimization, always remember to avoid data leakage, you don't use test set. You only use the training set. Divide your data into two. You have the 70% for training or 80% as the case may be, or whatever you decide. 20% for testing. That 20% for testing should be taken outside the building block. Keep it somewhere. You must never expose it to your system. Never. We've seen a lot of people made this mistake. They use when they are doing the hyperparameter optimization, for example, when K is equal to 1 for K nearest neighbor, they train it and they bring in the testing set to check the result. It's not good. They check K is equal to 3. They bring in the test set. So what you are doing in SN is you are adjusting K to the testing outcome, which is not correct. So the testing set must never be used for the building of the model. We have to take note of this. Very important. Otherwise, this is what we call data leakage. You see, you are leaking the testing set to the system. Because while adjusting the hyperparameters, you are using the testing set to see if it is okay now. No, that's not the right thing to do. So when you have data set, maybe you have like 1,000 samples, divide into 70 or 80% training, 20% testing, which is 200 for testing. Keep that 200 outside your building block. Now, consider this 80% as the only data you are having. Now, go inside and do the training. You can use the cross-validation, in which case you use the 80%, which is now 800 samples. You use it for tracing and testing like 10 times, 10-fold cross-validation, and then you check the result. Use it for the hyperparameter optimization. You never bring in the testing set. Keep it out. You can also, that 800 sample, you may decide to divide into 2 again. Another training and testing. 70 for training, That is 30 for testing. From that 800, divide into two. Use the first one for training, the second one for validation. You can keep doing that. Once you build, you are done with the hyperparameter optimization, you build the final model, then you now bring in the test set to check if what you build is okay. This is very important. We've seen a lot of mistakes from this angle, where people use the test set during the hyperparameter optimization. It should never be used. It should be kept outside the building block. So this continues until you get what you are looking for. Sometimes you have to do the data downsampling, the attribute downsampling. So sometimes you have to do feature reduction using PCA, principal component analysis. There's so many options we can try. However, while you are trying them, make sure you are keeping the result. Once you do one pre-processing on your data, that is a new variant of data you are getting. You see? Run the experiment again, do the modeling. See what that data, new. Okay, so like I was saying, we try as much as possible to keep the result of every experiment we've carried out, because we are not really sure which of these pre-processing will give you a better result. So we don't assume, we don't force our own opinion on the data, but we let the data speak. This is doing it right. And this is why we've proposed a multi-channel approach to pipelining. We call data pipeline, where you build a pipeline, a particular set of procedures to be followed in your experimentation. A single pipeline will not work. We need to have multi-channel pipeline. One pipeline is using the normalized data. Another pipeline is using the original data without normalization. Another one is using the one that has undergone log transformation. Another one is using the one that has converted text to number. So you have several options you can try your data. Put this thing in parallel. Let them go in parallel. And that is why data science and machine learning is better done in a team. When you have a project to solve, the best thing for you is to let it be in a team. So the team because of the number, you can distribute the tasks. You work on original data, you work on the parallel, the normalized data. You have different variants of the data set. And for every variant of the data set, you may have to carry out hyperparameter optimization for them, because variant of data set means they are no more the same thing. When you carry out feature selection, you have 20 features before, now you're having 5 features. So you can't say that data is the same thing anymore. You have to do hyperparameter optimization to be sure that you are getting the best from your data, that you're able to understand the whisper of your data set. So having said that, in a multi-channel pipeline, so you have one going this way, another one is going here, another one is going here. You have multiple, as much as you can. Once you carry out one pre-processing on the data, it means the data is a new variant. Put it in one pipeline. Do another one. Then run it, and finally you have the result. Gather the result, compare them, and come up with the one that is better for you. It's not a case of making up your mind. Okay, I'm going to use, my friend use deep learning. I'm going to use it. No, it doesn't work that way. It doesn't work that way. Deep learning may work for one problem, it may not work on another problem. See? One of the very unique advantages of deep learning is the ability to extract features automatically. So when you have real life project, for example, autonomous car, you want a car that drives itself, so you need a lot of videos, images to be taken in real time, sent to the processing unit to be able to determine, Is somebody crossing the way? The car need to stop? Is it too close to the next car in front? So many processing is going on or are going on at the same time. So what do you do in that case? Deep learning, you can't wait for human being to come and help you extract the feature. Deep learning gives you that flexibility. It automatically extracts the feature. But once it extracts the feature, the smart thing to do is those features, let deep learning find the final value for you, the final outcome. At the same time, pass those features extracted by the deep learning, let it go to ordinary k nearest neighbor, let it go to ordinary deep decision tree, that is in an hybrid setting. This is called an hybrid model. Deep learning has been used to extract the feature, but those features will now pass it to other standard machine learning algorithm, and also we let the deep learning work on it. We found out that when you do this, we've gotten better result with simple algorithm. Although the feature was extracted using deep learning, simple algorithm proved to have gotten better result even than the deep learning itself that extracted the data. These are some of the principles we expanding by saying, let the data speak. You see, when you have video, images, text, as I'm talking now, you want my voice is being taken by our AI companion in the Zoom, and you can ask it to translate it to multiple languages. You can ask it to make a summary. How is he able to get it? That is the power of deep learning. You see, as I'm talking, it's able to extract features from my voice, be able to recognize it, and be able to work with it. Those are the power of deep learning. See, so you have to know which model to try in which situation. And that is why experience matter when it comes to AI and machine learning. And practice is also very crucial. Whatever little you've learned, try to see how you can practice it. Before we end it for the day, they will take us to this. I said, irrespective of your background, wherever you come from, there are different angles to solving problems using AI-based solution. We have two people from diverse background. You think and brainstorm about your area of specialization or your interest and see how you could utilize machine learning towards improve outcomes. Get data set. You don't need to develop your own database for the beginning. Get online data set free. See, I'm happy to know that in some of our, you can see some of in our engagement, the WhatsApp group we have now a group of groups. We have some research groups. So one of our research groups, we have this Geospatial, they're making a lot of progress in their collaboration in publishing, maybe 2 book chapters now, journals 2 or more. Another group also will be working in past also, they have been trying their efforts. The energy group, we appreciate their leaders. We all collaborate together. Of recent, we have the Agric group, people who are interested in using machine learning and AI to solve it, towards solving agricultural related issue. We have several series on plants, that is how to have better yields in crop production, AI in crop production. We have several ways of engagement here. Later, we also started for animal production. We have also had several ML engagement on how can we use machine learning to work in these areas. And then after that, we formed that group, the research group. Anybody who is interested can join any of the group. Once you join our WhatsApp group, you great apology for the on and off today. So we don't know what's really going on since our network today is not stable. So like I was saying, under the leadership of Professor Taufik Yekin, their first paper is ready, which is under review by my Obu self, where they're trying to use machine learning. So in the same way, wherever background you have, try to see what can I do. You don't have to be an academic, but machine learning, but practical. You have to try what you've learned. Come up with an idea in your own area. So wherever you are a medical doctor, how can you use AI machine learning to facilitate and support your own work? It's not about replacing you, but about making your work easier. Having a machine learning standalone system that can diagnose your patient while you are busy with more chronic patients, it will be a better one. Some patients in the hospital, they don't really need to see doctor. Diagnose them, let them see the nurses to guide them to where they're going to get their drug. They have to go home immediately. So a lot of other stuff like that. So we have covered agree, we've covered animal production, crop production, we've covered a couple of other fields. Also getting requests from people, when are you going to cover so field? We'll be taking them one after the other, by the grace of God, to see how we can use AI and machine learning in some of these selected areas. Engineering have been covered to some level in the past, so we will still be coming back to that, while also looking at other areas. So the point we are making is that irrespective of where you came from, you can always benefit from AI, machine learning, using it to see how you can make life better and do better precision-oriented decision-making, precision crop production, precision-oriented animal production, and also for that, even the political system is not left out. We have one of our member here, has been a regular member for some time, for a long time, working presently on how to use machine learning to predict election outcome, to predict if there's going to be apathy to election or not. And also for that, actually, areas we can think of and see how can you have a kind of an idea of how you can be a part of it and benefit yourself. To the people from computer science related background, you also, the world needs you to come together and see how you can solve problems for them. See, this technology has provided very big opportunity for us. How can you solve problems for people? Develop new algorithms that can take this to next level. Develop new improved framework, like the idea of let the data speak we are talking about, which is coming to really change the way people look at machine learning modeling. So rather than going too deep into pre-processing, 70% or 65% of time are spent on pre-processing. We found out that some of those pre-processing may not be necessary in the real sense of it. So why don't we reduce the number of pre-processing and use multi-channel pipelining technology being proposed and see how we can get this done faster without missing the insight and whisper that our data set is bringing to us on daily basis. So once you pick an area, then you move to the modeling stage and then see how far we can go. To those people who are joining for the first time, you're all welcome. Even if you are joining for the first time, it's not difficult. You can always meet up. Join the WhatsApp group. Most important videos, there are 4 videos you'll be asked to watch to be shared with you on the WhatsApp group. After that, you'll be asked to watch another 3 sets of videos where you'll be able to deploy, to build your first machine learning model in weaker environment within a couple of hours. We've tested it. Several people have passed through it and they have given a lot of feedback how easy it is for them. So we all welcome on board. It's not difficult. So where are we going to start? It's easy. As you watch those videos, note it down, whatever is not clear. And then we can always ask questions as we are going to go into question time now. Every week when we meet, we always have question time. So it's an opportunity for you to note down whatever is not clear to you, and then you can ask the question. And then another opportunity is coming the way of everybody as a revision for those who are already learning with us for a long time. And for those who joined recently, it's a real opportunity for us that by next week, at the grace of God Almighty, we are going to start our summer training, which is going to be it's going to be 2-day intensive training, Saturday majorly, and on the evening of Sunday, the second day, but toward the evening. But Saturday will be the main training part, 8 a.m. to maybe 4 p.m. The timing will be provided, as the case may be. So it's an opportunity for us, for those who have been here before, to review revise what we've learned. And for those that are new, to now start afresh, because we're going to cover everything from the beginning to some of the areas we have. We have to track one next week, inshallah, which is going to be on introduction to machine learning. And the second track will be the upper week, which is going to be machine learning for researchers, for those who want to use it to build, in their own research endeavor. So these are some of the stuffs we have in store for us. That's going to be August 30, 31, and also the other will be the week that follows, 2025. So wishing you all the best. So I believe this is where we're going to have it for the day, and then we're going to call it a day. If there's any question, then we can let us know. Thank you very much, and God bless. Thank you.